Formal charges are commonly used in chemistry. We will use the formal charge as a bookkeeping method. It will allow us to judge the quality of the Lewis structures we have drawn. Essentially, we will count the number of electrons belonging to each atom in the structures we have drawn. We will compare this to the number of valence electrons we would expect the atom to have. This allows us to see if the electrons have been distributed throughout the molecule as expected. When we compute a formal charge on an atom, we are comparing the number of valence electrons that an isolated atom would have. This is the number we get from seeing what group the element is in on the periodic table, with the number of electrons that are assigned or owned by the atom in the Lewis structure that we have drawn. Be careful, this is not 8 based on the octet rule. The textbook presents an algebraic formula to compute the formal charge on any atom. It states that Fc equals Ve minus the sum of Nb plus 1/2 of Be. Let's define these terms. Fc sub A is the formal charge on atom A. Every atom in a Lewis structure has its own formal charge. We can apply this equation to every atom in the structure. Ve is the number of valence electrons in an isolated atom. This comes from the group number on the periodic table. Nb is the number of non-bonding electrons. These are shown in Lewis structures as lone pairs. Be is the number of bonding electrons. These are shown in Lewis structures as shared pairs. Notice the 1/2 in front of Be. We assume these bonds to be covalent. In other words, one electron in each shared pair belongs to one atom, while the other electron belongs to the other atom. Each atom owns half of the electrons it shares with its neighbors. The number in parentheses in the equation gives the number of electrons owned by that atom. Rather than memorize this equation and use it repeatedly, it is often easier to assign formal charges by a visual inspection of the Lewis structure. For example, there are 2 resonance structures of the molecule sulfur dioxide. Let's assign formal charges to each atom simply by looking at the structures. For each, we need the number of valence electrons for an isolated atom and the number of electrons owned by that atom, as drawn in the structure. The formal charge is found from the difference. Start with the left-hand oxygen in the left-hand structure. There are 6 valence electrons in an isolated oxygen atom. To count the number of electrons it owns, first count the non-bonding electrons in lone pairs. 1, 2, 3, 4. For the purpose of ownership of the bonding electrons, we mentally bisect the double bond to show that the oxygen owns 2 of the 4 bonding electrons. Sulfur owns the other 2. This gives oxygen ownership of 6 of the 8 electrons around it, 4 in its lone pairs, and 2 of the 4 it shares with sulfur. Taking the difference results in a formal charge of 0 for the left-hand oxygen. For sulfur, the periodic table tells us there should be 6 valence electrons in a sulfur atom. Sulfur has 1 lone pair, or 2 non-bonding electrons in the Lewis structure. We'll indicate sulfur's electrons with blue arrows. Sulfur owns 2 of the 4 electrons it shared with the left-hand oxygen. If we mentally bisect the single bond, sulfur owns 1 of those 2 electrons. In total, sulfur owns 5 of the 8 electrons around it. The 6 valence electrons minus the 5 it owns gives sulfur a +1 formal charge. For the oxygen on the right, Ve is 6. The way we have drawn it, the lone pair on the top gives 2, the lone pair on the right gives us 2 more, and the lone pair on the bottom gives us 2 more, for a total of 6 non-bonding electrons. Add 1 of the 2 in the single bond with sulfur, and oxygen owns 7 of the 8 electrons around it. 6 minus 7 gives us a -1 formal charge. Before we assign the resonance structure on the right, we invite you to pause this presentation by clicking on the pause button and find the formal charges of all 3 atoms on your own. How did you do? Let's compare our answers. To find the formal charge on the left-hand oxygen, we need to mentally cut the single bond in half. When we do so, we see that oxygen owns 7 electrons, all 6 in the lone pairs, plus 1 of the 2 in the bonding pair. Subtracting 7 from 6 results in a formal charge of -1. For the sulfur in the middle, we mentally bisect the double bond to the right-hand oxygen. We see again that sulfur owns 5 electrons, 2 in its lone pair, 1 from the single bond, and 2 from the double bond. 6 minus 5 results in a formal charge of +1. For the oxygen on the right, it owns 6 of the 8 electrons around it, 4 in the lone pairs and 2 of the 4 in the bonding pairs. Subtracting 6 from 6 results in 0 formal charge. Formal charges are indicated on Lewis structures by placing a plus or minus sign in a circle and putting that charge next to the atom. For the first resonance structure, the right-hand oxygen has a -1 formal charge, so we place a minus sign in a circle next to the oxygen atom. Sulfur has a +1 formal charge, so a plus charge in a circle is placed next to the sulfur atom. There is no rule for exactly where the charges are placed. Just put it as close to the atom as you can. In the second resonance structure, the left-hand oxygen carries a -1 formal charge, and the sulfur again carries a +1 formal charge. We place the signs next to the atoms. Notice that in each resonance structure there is 1 positive and 1 negative formal charge. In any Lewis structure, whether it is for a neutral molecule or a polyatomic ion, the sum of the formal charges must equal the overall charge on that molecule or ion. In this case, they equal 0 because this is a neutral molecule. If your formal charges do not add up to the overall charge, this tells you that there is a problem with your Lewis structure or your formal charges.